Hello guys, welcome to our YouTube channel CIT Innovation, where innovation means imagination. Today I am here to explore a new project idea, that is hardware implementation of fault analysis, transformer protection, overload sharing in power station, and the whole system using PLC, that is programmable logical control. It is a total core electrical project, and this whole project can be classified into three parts. First one is generation unit, second one is transmission, and third one is distribution. It is a core electrical project. So before going to demonstration, introducing myself, I am Sobit Poddar, a student of Camilla Institute of Engineering and Technology from Electrical Department. Now, no wasting more time, let us demonstrate our project. Now, come to the point, generation. Generation means generation of electrical power, that means conversion of mechanical energy into electrical energy. For the project purpose, consider it is a generation unit and it is a DC motor, and that DC motor is coupled with a synchronous machine that generates up to 270 volt AC, and that is enough for the load. In industry, we are used AVR. It is a AVR which I have device controlled through using microcontroller. It is a AVR. We create a voltage monitoring device using microcontroller, basically Arduino Nano, and ZMT301 voltage sensor that continuously detects the under voltage, normal voltage, and over voltage conditions. There is some conditions is that when the voltage limit is less than 180, then the voltage is called under voltage, then the load is off, and over voltage limits when the voltage is greater than 230 volt, then the load is again off, and when the normal voltage limit, when the voltage is between 180 to 230, then the load is only on. Now let's come to the point project working principle. Now come to the point controlling unit. When this controller is controlling this AC voltage which is generated, that also be controlled. Here you can see that the voltage is now 87.2, that is now under voltage. When voltage is increases rapidly, and when this voltage is above of when 180, then the normal condition will done. Now when the normal condition will done, the bulb will glow, and when this voltage is again growing and going to the above of 230 volt, just see increasing of voltages, 230 volt, above of 230 volt, above of 230 volt. Now the voltage is some over voltage, and during that condition load is off. It is bus bar. It is the main part of the whole transmission line, after which the whole transmission process will continue. This contains a lightning arrestor, switch gear, CT, PT, circuit breaker, etc. And in the transmission line, always the voltage can be transferred at high voltage. That can be 11 kV, 33 kV, 765 kV, etc. But for the project purpose, we only sending the signal that can be 0 and 1 through this transmission line. Now, as we all know, in transmission line, basically three types of fault occur. That is line to line fault, line to ground fault, and line to line and ground fault. Through this whole project, we can describe three types of fault. First one, line to line fault. Let us take a consider it is an wire and it is an wire. This is an wire and this is an wire. And this wire is connected to this, and when I touch this, the load is off. That is, it fully describes about the line to line fault. Now come to the point line to ground fault. It is the ground floor. When this line is fall on it, then also the bulb is off. That means it also works to line to ground. Now It is, we all know, for protecting any device, we require protection type of device. Here we use different types of short circuit detector. Here we use relay, that is 5 volt relay, it is 12 volt relay, it is 24 volt relay, again 12 volt relay. And these whole relays, as we know that the relay operates from a normally closed to normally open when the required voltage is obtained through the required level of voltage. That means let us consider that a 5 volt relay, it operates when the voltage is 5 volt, and a 12 volt relay that can operate at the voltage of 12 volt. A 12 volt relay cannot operate at the voltage of the 5 volt. So considering this concept, we build up this. Then when the generated voltage is only the 5 volt, then the 5 volt relay is on, and when the generated voltage is 12 volt and gradually increases, then the other relays are on. Now come to the point, protection. Which type of protection? Now what is this? It is a short circuit detector. It is a short circuit detector. Now you see that the green light is indicated. That means the whole system is now ongoing, and you see that the green light is glowing. Now in case short circuit occurs, now it is a busbar model. Now I short this. Just see, load is off and red light is indicated. That means short circuit occurs. There is the presence of fault. We have to prevent this, and by resetting this switch after considering the fault, we can again activate our load. That is keep in mind. Let us consider in case there is any fault in the generation unit. Generation unit, this is the generation unit. In case, let us consider this two terminal is showing short. Now this short circuit detector also protects the whole system. Now the red light is indicated that the whole system is cut off. Whole the system is cut off. Again, now when I resetting the switch, again the generation unit is start. Now come to the point, we also require transformer protection. It is a transformer that also requires a protection. That can be short circuit protection, that can be temperature protection, that can be CT protection, that can be PT protection, etc. Here we also discuss about only the temperature protection. Now the temperature is 32.2 degrees Celsius. When this temperature is going to 40 or 40 above, then the transformer is cut off and the whole system is being again cut off. Let us take an example. Now when the generation unit is going rapidly, and I only choose this, and now this light is going, that the generated voltage will glow this light. Now in case of any fault occurs in the system, just see. Now the light is off. To this buffering, they do some reason, it is cut off, and this now it is cut off. Now it is known to all that the generated voltage is increases rapidly. That means first is 100 volt, second 200 volt, 230 volt, and that process. As we all know, turbine rotates, and during up to which the generated voltage is done. Here, to understand that, we have used here a voltage regulator. To build up this voltage regulator, we use IRZ4NN N-channel MOSFET and 100K preset. Now, when the voltage is low, then it says that this load is off. This load is now off, and when the voltage is gradually increased, rapidly, then the light is glowing. That means such a voltage is when generated at the certain limit, then the load is on. Otherwise, the whole load is off. That is also called, it is under voltage condition also. This can protect our devices, that is basically used in our distribution side from protection. That the during under voltage, if we run any equipment at under voltage, then the equipment will damage, and this whole system can protect our devices from damage. As you all know, in the transmission line, there is the presence of insulator. In case corona effect or any high voltage passes through this transmission line, sometimes insulator will break and they can damage a fire, and a fire occurs there. Here we use this fire extinguisher sensor that detects the fire, and during that detecting, it can cut off the whole load. That is done. and it is the whole project through which whole the transmission line fault analysis, overload sharing, transformer protection, and not only protection for the generation unit, also for the protection for the distribution purpose, and the transmission line project is done. And this whole project can also be done through our softwaring project, that is MATLAB, and also can be used for PLC. So, we will do this. Subscribe our YouTube channel. Thank you.